Hello and welcome. This is going to be our homework help video for the two variable inequalities and piecewise homework. Let's just start with graphing some of these linear inequalities. What we want to do for a problem like number 3 here is treat this like it's just a y equals mx plus b problem. But when we go to graph that, we're just going to dot the line across the graph and then make some more decisions. So let's look at this. I've got a slope. That's not my slope. I got a y-intercept of 1 and a slope of negative 1/4. In order to graph this, I put a point at 1 at my y-intercept, and then I'm going to go down 1 over 4. Down 1 over 4 going to take me off the graph, or I could go up 1 backwards 4. That would still be a negative 1/4 because I'm going backwards as part of it. Notice so those make a straight line. Don't connect them up yet. Now we got to refer back to the problem. I see this is a greater than or equal to. If it has that or equal to, we want to connect these dots up with a solid line. So solid line going right through all of those dots. Now I refer back to my inequality. It's a greater than. Greater than means shade above. So less than or equal to, we're going to shade below. Greater than or equal to, shade above. And now we've represented all of the solutions in this shaded region and the line itself that make this inequality true. To double check it, I'm going to pick a point somewhere out over here, maybe like 4, 4. I'm going to plug it in. Is 4 greater than negative 1/4 times 4 plus 1? Is 4 greater than negative 1 plus 1? Is 4 greater than 0? It checks out. It means we've probably shaded correctly here. Let's see. Towards the bottom of the page, we've got some that are given in standard form. What are we going to do with that? Well, we're going to convert it to a slope-intercept form. I'm going to use the space over here to do that. 6x plus 5y is greater than or equal to 5. I'm going to subtract 6x from both sides. We have 5y is greater than or equal to negative 6x plus 5. Divide both sides by 5. And I get the inequality y is greater than or equal to negative 6/5 x plus 1. Now, if I divided by a negative number, I'd have to remember to flip my inequality. This is a common time to forget to flip it since we're doing a different type of problem. Let me put a point on my y-intercept of 1. The slope is to go down 6 over 5. Or I could go up 6, backwards 5. It's the same effect, makes a straight line. I'm going to connect this one up with a solid line, just like the other one, because it has that or equal to part to the inequality. Actually, I should be pointing down here. It has this or equal to part to this inequality. This one is a greater than inequality, so I'm going to shade above my line to the greater than side. All right, I think we'll call that good for this half of the homework. Let's flip it over to the back side where we're graphing equations piecewise. Here's how we can do this. First thing we look at with a problem like number 9 are the transition values. Negative 1, it's repeated here, and 3. Once I've identified my transition values, I'm going to add in vertical dotted lines at those values, splitting my graph into 3 strips. 1 and 3. All right, so you got the first strip over here, a more narrow second strip, and a third strip over here. Now these are always going to be set up so that my top equation is my leftmost strip, middle equation goes in the middle, bottom equation goes furthest to the right. To help us graph this, I'm going to write it with a y equals. You can always say y equals, and then whatever we see here after the bracket but before the comma. So this first one is going to be y equals 5. And that one's going to be valid. I'm going to go ahead and graph that all the way across the graph to start. But then I'm going to say that's only valid in the first strip, so I'm going to erase the other pieces of it using my vertical dotted lines to help guide me where I want that to stop. Then I have to decide on an endpoint here. This inequality has that or equal to, so I want to do a closed dot. Closed dot when we see that or equal to part. Second one is the equation y equals 2x. You can graph that. That's got a y-intercept of 0, up 2 over 1, up 2 over 1, up 2 over 1. Just going to have this go out of the bounds of this strip, and then I'm going to erase so that it's only in that middle section there. Now let's decide on our endpoints. At the -1 endpoint, that's just a less than. It doesn't have the or equal to, so we're going to do an open circle there. At 3, it's got the or equal to, so I want to do a closed circle at this ending point here. Next up, I've got y equals x plus 1. Well, let me graph that. It's got a y-intercept of 1. So kind of slope of 1, come up over this way. Erase the part that isn't in the correct strip of our graph, which is down here. This gets an open circle because of that inequality. Doesn't have the or equal to finish off our graph. So 3 different pieces. They all look kind of different. They're all straight lines. Let's try, where did it go? Oh, I lost it. All right, I did 11 and 13 in the PowerPoint, so you can check on the PowerPoint for those ones. Let's do 14 since it's got this absolute value bracket as one of our functions. Might make things a little bit more challenging. What's our transition value? Our transition value is 1, so I'm going to add in a dotted line at 1. To the left of this dotted line, I want that top equation to be the one that's being graphed. To the right of it, I want that bottom equation to be the one that's being graphed. Let me write this with a y equals the absolute value of x plus 4. This is going to be our V-shaped graph, but moved 4 left. So let me do a V-shaped graph that's been where the vertex has been moved 4 left. Just going to make it go to about there on that side, all the way across the graph here. Erase the portion that goes past our transition value. This has the or equal to, so right at that transition, I need a closed dot. Now this next equation takes over. I'm going to rewrite it with the y equals to help myself out. Y equals x minus 1. Put a point on my y-intercept of -1, attach a slope of 1. Go all the way across the graph over here. Erase the part to the left of that transition value, and then end this with an open circle. All right, let's just real quick practice something we were doing during class. Let's evaluate h of 3. What does that mean? It means I go to 3. I see where it hits my line. It hits at the elevation of 2, so h of 3 is equal to 2. You keep practicing that in class, evaluating functions with function notation. All right, well, have a good rest of your day. That's the end of this video.